I have recently repaired the speedometer of my motorcycle, and now I want to verify the accuracy of it. I can do this because I have a tachometer on the motorcycle, and with a little bit of math I should be able to check it against the indicated speed of the speedometer to tell if the speedometer is fast or slow or correct. I need a little bit of information before I get started. I need to look at a few things on the motorcycle itself. I need to count the number of teeth on the front sprocket. In this case it's 15. The number of teeth on the rear sprocket, I have 46 teeth on the rear sprocket. And I also need to calculate the circumference of the rear tire. To find the circumference of the rear wheel, I took some small wire and wrapped it around the outer edge of the wheel, and then marked the wire and measured it with a tape measure. This gives me the circumference of the rear wheel, and it also gives me the distance the wheel travels for every revolution. Now back in the office, I will write down my findings. The rear tire circumference, 83 5/8 inches, which is 83.625. Rear sprocket teeth, 46. Front sprocket teeth, 15. Now I need to find out the gear reduction from revolutions of the engine to the final drive sprocket. After I have this information, I will have a final ratio of engine revolutions per revolution of the rear wheel. To find the necessary information, you can check your owner's manual, or usually you can find the information online. I found the information in my owner's manual. You could also call your local dealer, and they should be able to tell you the necessary ratios. The first ratio to consider is the primary reduction. This is the reduction from the actual crankshaft speed to the transmission speed. In my case, it is 2.392. So we'll write that down, 2.392 primary. The next reduction is the final reduction, which is 3.066 from the factory. This represents the drive chain reduction, front sprocket to rear sprocket. My motorcycle has a 15 tooth front sprocket, 46 tooth rear sprocket. So if you divide 46 by 15, you get 3.066. Repeating. The next ratio to consider is the gear ratio. This gives the ratio of the transmission speed to the rear sprocket speed. It shows gear ratios for every gear. I'm going to be doing my test in 5th gear, or top gear. The ratio for top gear is 0.826, so I'll write that down. So now, if we trace back all the way, we can now figure out the final ratio of engine revolutions to rear tire revolutions, and then from that figure out how many revolutions per distance traveled. Now I will multiply all of the gear ratios together. The primary, the 5th gear, ratio, because I'm going to be doing my test in 5th gear, times the final drive ratio. The result I get is 6.0578. The next step is to pick a test RPM. This is the RPM that the engine will be spinning when you check your speedometer to check for the accuracy. I will choose 3000 RPM. I do 3000 RPM divided by 6.0578. The result is 495.2293. That means that when the engine is spinning 3000 RPMs in 5th gear, the rear wheel will be spinning 495 RPM. The next step is to multiply the rear wheel RPM times the circumference of the rear wheel. In my case, it would be 495.2293 times 83.625. The result is 41,413.55. This is the speed my motorcycle is traveling at 3000 RPM in inches per minute. Now I will multiply this number times 60 to get the speed traveled in inches per hour. 2,484,813 inches per hour. There are 12 inches in a foot and 5,280 feet in a mile. If you multiply 12 times 5,280, you get 63,360. Now we divide our inches per hour by this number to get the speed in miles per hour. My result is 39.22 miles per hour. So now it's time to ride the motorcycle and see how we do. So I went on a ride, and at 3000 RPM the speedometer actually read 42 miles per hour. So now we need to take apart the speedometer and adjust. I removed the needle and the face of the speedometer, and I can actually adjust this one with the main mechanism still in the gauge case. I have another one that's out of the case to give an idea of what you need to look for. There is a cup that spins. This controls the needle. And there's a spring up there that puts tension on the cup. The more tension that you have on the cup, the slower the speedometer will read for a given speed. There is an adjustable stop right here, and if you adjust it so that the spring is pressing tighter, that will lower the speed of the speedometer. And that's what we need to do in this case. We need to we need to put a little bit more pressure on the spring. So we move the stop a little bit clockwise to put a little bit more pressure on it, and then we will test again. This is a lot of trial and error. Just move the stop little by little, testing each time until you get to what you think is a good degree of accuracy. I am now ready for trial number 2. I just taped the glass and ring on for right now because it takes a long time to crimp and uncrimp this ring, but I feel it's necessary to have the glass installed because I don't want the wind blowing the needle as I'm driving. So I will test it and see what happens. I'm back from my ride around the street, and test 2 was right on the money. 3,000 RPMs indicated a 39 mile per hour rate of speed. Thanks for watching.